Hello and welcome back to SAS From Scratch. Today we're going to be busy with episode 4. This is the one that I mentioned last time round was going to be a bit of a doozy because we've got a lot of stuff that we need to go through. And as you can see from the title there, we're going to be looking at, among other things, how to import data. We're going to learn about the where filter, and we're going to learn a bit more about the output statement in SAS. So let's get started. One of the first things we're going to look at today is something that's very similar to the libname statement that we've already seen. So where the libname statement allows us to create a reference to a folder, the file name statement is going to allow us to create a reference to a particular file which is on a disk. This is very useful when we work with PROC IMPORT, as we'll see shortly, but it's not compulsory that you use this. You can also just reference the file name directly. The most important thing we're going to look at today is the PROC IMPORT statement. This is it's not a statement, it's a procedure. This procedure allows us to import raw data files. So when we talk about raw data files, we mean Excel, comma separated values. Maybe they're tab delimited or space delimited, or they use some sort of custom delimiter. And then there's some extra ones as well. So we're not going to look at jump files. That's completely outside the scope of this series. But it's quite versatile and offers support for a lot of formats. We can look at the syntax down below. So this is what your PROC import looks like. We've already seen when we work with PROC sort or PROC contents, certain keywords stay the same, like out, for example. In this case, we have a data file parameter, which is either going to be the file name directly, or it's going to be a reference to the file. That follows on from our previous slide, where we learned about the file name statement. Table with a particular table name is when we work with access data files. Now access, it's another one of those tongue twisters. Access to the SAS Access engine is, I believe, again limited by a license. So if you do not have this license, you will not be able to directly work with access data files. It is possible that I'm wrong about this. It might be included in the base package, but I believe that it's not. The out statement we've talked about, we've worked with this before. So that's the two-level location where the data that we've just imported from the raw format should be exported to. And when that is exported out, that's going to be in a SAS dataset format. So we can have it as work.something, we can leave out work, or if we've mapped a more permanent library, like what we did in episode 3, that can be written permanently to a disk. And this is what you're going to want to do in most cases, is to get something from a raw format, like a CSV or an Excel file, into a much more structured format, like a SAS dataset. And then from that point forward, you'll keep that dataset pristine and preserved, and you will be treating that as the source instead of the Excel or the CSV file. The replace keyword that we're looking at here is an instruction to SAS that it should overwrite the dataset if it already exists. It will not do so by default, so if you do not want SAS to be overwriting datasets that already exist, you simply leave out that keyword. DBMS, or Database Management System, that word is doing quite a lot of work in this scenario or this instance. I would not consider Excel, CSV, or any kind of delimited file to be a a database management system, but that's just the keyword that they've chosen for this. And then there's a couple of other keywords that we just need to be aware of. The first being the delimiter keyword. So when you specify that the DBMS type is DLM, delimited, that means you've got data, and we'll see some examples of this when we jump to SAS Studio just now. You've got data that's separated by a certain character. So this is a character that normally you wouldn't expect in your data, or if it does come up, for example, if you've got a comma separated value file, which also has commas in the data, you would need to basically escape those commas to prevent your procedure doing the import to see that as a new record instead of just part of an existing, or instead of a new value, part of an existing value. The get names option is by default yes, so you don't need to worry about that, provided that the first row of your data is the column names. If you don't have that in your data, you would have to specify that to get names equals no. And SAS would then put in default names. I can't remember exactly what the defaults are, but we can look at that maybe in an example later. Guessing rows. So when you're working with raw data, the default number of guessing rows that SAS is going to be looking at is 20. So that means SAS takes the first 20 records of your data set and it tries to guess what the data types and the formats, etc. are. So it might it might see, for example, that the first 20 records of a particular column are all numeric, and it might then assume that all subsequent rows are also numeric. Now the danger in this, if your guessing rows number is too small, if you've worked, for example, with concentration data, let's go back to the healthcare sector, that's what I know. If you've got plasma concentrations and you'll have a certain number of values in there, so you'll say, okay, well, before the subject was dosed, the concentration of this product in the blood was 0. Half an hour after he or she was dosed, it was 10, and then 20, 50, etc. so on. Now, sometimes there's a problem with, for example, if the nurse tries to draw blood from a subject, maybe something went wrong, maybe the subject, it could be, many things can go wrong that just prevents that sample from being analyzed or from being taken, and then that sample is not available. Now, what you would get in your data then is that for that concentration, we can't just represent that as 0 because that's not truthful. So what we would have to do is to say, okay, well, that concentration value is either NA, not available, or it's NQ, not quantified, or NS, it was not sampled in the first place. And then the problem is if, for example, that NQ, NS, or NA is somewhere 500 records down the line and SAS only looks at the first 20, you're going to be missing that data. So SAS will either, that's a good question, I don't work with raw data a lot, but SAS will either tell you, oh, well, expected a numeric and now that's a character. It might simply ignore the character and return a missing value back to you, so a dot. But that's the danger of having a guessing rows number that's too small. You could simply set that to guessing rows equals max, and we can look at the option. That's going to be more or less the safest option if you're not very confident in in the in the data that you're looking at. So what I mean by not very confident is you don't know, for example, in this file that you've got that maybe has 5 or 10,000 rows, you can scan through it, and it's hard to do. If you've got a CSV file, for example, the data will be all wavy like this because you've got different lengths in each column. So you've not got a neat structured data that's lined up that you can quickly browse through. It's very difficult to look at it. And if you're not very confident that everything in a certain column is going to be numeric, and that assumption isn't safe to make, you would rather say guessing rows equals max. You would spend a little bit more time having SAS determine what the type should be than losing data or maybe getting an error somewhere down the line. Then we've got the data row option. Now that simply tells SAS on which row does the data start. For most records or data sets, raw data sets that you're going to be working with, you're going to assume the first record is the names row, and then everything else thereafter is data. But it could be that, you know, maybe there's like a names row and then a row for labels, and then only does the data start, in which case you'll want to set data row to one record further along. And then the last one there, not something that we're going to look at too much today. LREC-L is the logical record length, and so what that's basically referring to is in every record that we've got in this raw file. So if we've got a CSV file, comma separated values, how long is each record going to be? And that's kind of, if you added up the lengths of all the columns, how many bytes would you get? So by default, it's 256 characters, I believe, or 256 bytes. You can up this to about, so it's 32k minus 1. So I think that's, I think it's 32767 is the maximum record length that you can put in there. Now, as always, when we're dealing with lengths in SAS, that's space that's being reserved. So if you make that number unnecessarily large, you're going to be reserving more space in memory, for example, than you might otherwise like to. The good news is that in this day and age, we are not too worried about storage. Especially RAM is cheap and disk space is cheap. But the idea is, as always, I used to have an algorithms textbook back in university that showed, for example, the difference between a well-written algorithm and an optimized one versus one that is not optimized, and you know, maybe executes more steps than it should. And even on modern hardware, you can have a massive difference between code that's optimized and not optimized. So even though you don't need to worry too much about that, for me it always comes back to making sure that something is as well written as it can be. It comes back to something we've talked about, I think, in episode 1 or 2, which is to take some pride in your work and not just fling something at the wall and hoping it sticks. But for the most part, you can pretty much up the record length because we've got such powerful computers these days. Okay, that's the basics of the PROC import statement, and we'll look at a couple of examples. So here's 4 examples just to start us off with. This one is a .txt file, this one is an XLSX file, this one is a CSV file, and this one is again a .txt file. Now all of these, with the exception of the XLSX file, are plain text files. So you can even open them in Notepad and you can look at them. You'll note they all start with options valid var name equals v7, and so what that is telling SAS is if you are importing this file and there's maybe spaces in the column names, so if that first row we assume is the column names, and we do because here we have get names equals yes, then what that is doing excuse me, what that is doing is it's telling SAS if there's a special character in that column name or a space or something, strip that out and replace it with an underscore so that we have column names that follow the SAS rules for naming variables. Something just to take note of is you'll notice there's only a semicolon here after the replace. And the reason for that is that these 1, 2, 3, 4 lines here, they are all actually one line. So they belong to the same statement. They should actually be following along here in one line. But because there's limited space, sometimes it's easier to read. You might see a programmer stack them one below the other. And then put the semicolon after the last one. So you can't put semicolons after each line here because they're not separate lines. They all belong to this one line. In this case, for the txt file, we can see that we've specified our DBMS to be a delimited file. That means there's something, a special character in there that's separating the different values from one another. And in this case, our delimiter is an ampersand. It could have also been a pipe character. It could have been a comma. That's just a CSV. And our output is my data. So in the work library, we're going to be seeing a data set there that says my data, and that's going to be this data converted into a SAS data set. Moving on to the next one, if you followed along with episode 3 yesterday, you would have seen that if we have access to the Excel engine, we can work very easily with a libname statement with XLSX files. If we don't have access to that, we need to use a PROC import. We again have valid var name v7 at the top to make sure SAS forces the column names to be according to SAS rules. In other words, no special characters or spaces, doesn't start with numbers, etc. Our DBMS is now XLSX as opposed to the delimited one we had here. Our output data set is work.bootcells, and we've got another replace statement here. Just in case this data already exists, we'll replace it. If you did not want to do that, you could leave this out, and SAS will put probably a warning or an error in the log that says, sorry, I couldn't replace it because that already exists. A special option that we need to keep in mind when we're working with the Excel files is to specify the sheet that you're working with. You can wrap it in quotes or not. That's up to you. I prefer putting it in quotes, even though it's not necessary. And if your sheet, for example, has spaces in the name or something, you're going to have to wrap it in quotes anyway. And again, here we have get names equals yes. That's the default. We did not strictly have to put it in, but just to be very clear and transparent with what's happening, it has been added here. Note again, this semicolon here and no semicolon on the preceding 3 lines means that this is all part of one line. So SAS expects this as a single input statement. Moving on to the CSV file, we've set our DBMS to CSV. That's pretty much a delimited file where the delimiter is just a comma, but it's so prevalent and so common that there's a whole CSV keyword reserved for DBMS for it. This is again going to the work work.shoes dataset, so the work library and the shoes dataset. And in this case, it's been specified that get names equals no. So the very first row that SAS is going to import is going to immediately be treated as data and not column headers. Moving on, here we have another txt file. So this is just a plain text file, or as I've said, all these three are plain text. This is for states, presumably states within the United States of America. And here the logical record length has been changed from the default of 256 to 100. Presumably we know for a fact that all of these records are maximum 100 bytes or 100 characters or shorter. And so if you make it too short, if for example there's a certain record length that's longer than 100 bytes or characters as it may be, in the SAS log you'll get it'll be either a note or a warning, but if it's a note you won't get the little caution sign or the error sign in the title of your program, like we saw in some previous episodes. So if it outputs it as a note, you have to physically go and check your log and make sure that it imported correctly. But if you make it too short, SAS will say something along the lines of one or more lines or records have been truncated. And as soon as you see that note that says that you've got lines that were truncated, you know that your record length is too short and you're losing data. Note as well that in this case, so in all of these other examples, the data file simply points to a file name that's on the disk. In this case, we've created a file reference. So file name, the reference is states, and we've got this path here. And in this case, when we point the data file to something, we're not pointing it to an absolute path like we do here, but we're pointing it to the reference. And you can do it either way. It normally looks a bit cleaner if you use the file name statement, but it's not compulsory. This is again a delimited data set, so it's got a special character that's delimiting the different values. We're going to output it to work.myStates. There could have been a permanent library in front here. And we've again got the replace keyword. In this case, the delimiter is a space character. As I've said in episode 3 as well, if you see this little bracket in my syntax, that's just a space character to make sure that it's clearly visible and you don't have to guess what it is. So there's a couple of PROC import examples. You can see regardless of what we're importing, if it's text or CSV or Excel, they all kind of look more or less the same. Okay, moving on, we're going to do a little exercise. So in the files that I've prepared before I started recording this morning, and I'll show you the contents of the files as well, so that you can replicate them. But we're going to have a few files, and it's going to be an Excel file that we're going to import with dbms xlsx. There's going to be a CSV file. We're going to import it twice, once where dbms is CSV and once more where we're using just a delimited database management system, just to show you that it's basically doing the exact same thing. And then there's a vitals.dat file. Now we need to figure out what's going on in this file. It's in our case it's a plain text file, so we can quickly look at it and we can see what we need to do to import it. and then we'll decide on the way forward. So that one will be a neat little exercise for us to do. So I'm going to jump to SAS Studio from this point onwards, and I've already taken the liberty of creating these files for us. So if you were around for episode 3, we've basically got exactly the same Excel file that we were working with in the last episode. There's a bunch of shoe types and brands and prices in there. We've then also got this bonuses.csv file, and we can see an example of that, or we'll look at the contents of that very soon. And then we've got vitals.dat, which is a vital signs data set. It's very similar to something, well, not very similar, it's a bit more involved, but in the healthcare sector, you'll have data sets that, for example, record the vital signs of a patient, like the blood pressure, the heart rate, the weight, the height, etc. So the idea behind it is that there would be some vital signs in this data set, but we'll have to take a look at that, examine it in plain text, and first understand what's going on with it before we move on. So one of the first things that I need to do is I need to create a new program. So I can right click here, I can just say new SAS program, and I'm just going to immediately save it into this folder so that we don't lose any of the work we're doing. There's my program that's now in the file and folder browser. And one of the first things I want to do is to start a file name reference to the Excel file that's sitting here, because that's the first one we're going to look at. So let's keep it neat and tidy. I'm just going to do something like this. And this is very, very similar. Recall our libname statement from yesterday was something like this, mylib. And then you would put the path to the folder in between here. So we're doing basically the exact same thing, except today it's a file name statement because it points to a file and not a folder. And as we did yesterday, to get the actual path of where this is sitting, I'm just going to right click on this file, I'm going to say properties, and I'm going to just copy and paste this path. And that's our file name reference. I can save this, I can run it. We're not going to see too much, but it does execute this statement. And then we can start importing it. So I'm just going to make a comment here, and I'm going to say import Excel file. Excuse me. So we know how to do it. It starts with PROC import. We give it the data file we want to import. We could have given it the file directly, but in this case we're going to point it to this reference that we've created. We know our database management system. Again, that word is doing a lot of heavy lifting. It's an Excel sheet, and we can just say, let's export this to the work library, because we're not specifying a library. By default, it's going to go to work, and we want that to be called inventory, the data set itself. Now, it doesn't exist yet. I can prove that to you. So if we go to libraries, my libraries, and work, you'll see that that's empty. But I'm just going to put the replace keyword there by default. It's a temporary library. Maybe I'm going to be making some updates to the Excel file back and forth. Excuse me. And then I don't want to sit and delete that file every time and then import the new one. And then if I need to make more changes, delete it, import it, etc. So I'm just going to leave this replace keyword here for now. Then I'm going to close my PROC, because we're doing a PROC, we're closing it with a run statement. And I want to, we don't have to put it in, but just to be perfectly clear and transparent about what's happening, I'll add in the get names statement as well. Now, something that we know from yesterday is that our sheet that we were working with was called shoes. And this is something we need to put in now as well to import this Excel file. So the Excel file, the way that it's structured differently from a CSV file or something else is that it has different sheets within it, and we need to specify which one we want to import. So I'm going to run this and we should get output data. Let's take a look at our log as well. It's always good to take a look at it. This one I'm not going to worry about too much. It's just an example, but this is something that we should look into to see what data type it's complaining about there. So the import data set is 9 observations, 4 variables. Work.inventory was successfully created, and the import procedure was used. So we've got nothing weird in here that complains about data going missing or anything else. And if we look at this now, we see exactly the same values, the same rows that we saw yesterday when using the libname statement with the XLSX engine. So we're pretty confident that this executed properly. And the other thing that we will do is we'll be using this data set maybe later for some more exercises and examples. So we've now managed to import it into our work library, and we've now got a SAS data set. So we no longer have to work with we no longer have to work with an Excel data set. We can simply work with a SAS data set directly. Okay, we've got a little bit more work to do. So the next item on our list is this bonuses.csv file. Now a quick trick that you can do, you can either open this in, for example, Excel. Excel will happily read the CSV file for you. The other quick thing you can just do is there's this button in SAS Studio that says view file as text. You can open it in SAS Studio. You can open it in Notepad, anything you want. And if you've never ever seen a CSV file before, it's comma separated values, CSV. And what this is basically doing is each value is separated by a comma. So we've got a certain person here. So in this case, Abe, Bob, Charlie, Dave, and Ed. We've got a particular year. They're all 2023. And notice when I was talking earlier about your data being a bit wavy, this is what I meant. So it's very, very hard to see. Well, in this case, it's easy. But imagine you had 5,000 records in here and you had to make sure that there was not a year that maybe instead of 2023, it said unknown. That's very difficult to do. But in this case, we can quickly check, and that's all 2023. We have a certain month, so second, third, first, third, and fourth months of the year. And then a certain bonus value, maybe that's dollars or bitcoins or whatever you want it to be. But we can verify that this is definitely a comma separated value file. And we can import that. So let's, again, we saw you don't have to do this. I'm just going to do it for the sake of being neat and consistent. Let's go right click properties. We can copy and paste this path, and then we can do an import. So let's say import CSV file. PROC import, our data file is the CSV file. You could have named it anything you wanted. I'm simply going to call it CSV file because that makes the most sense. And good habits. Let's close our PROC import with a run. As always, I like being transparent about it, and I'm just going to put in the line that says get names equals yes, but it will do that automatically. And if I run, I also need to run this because if I don't run this, it should give an error. In fact, let's see what it does if that is not there. Okay. So here it complains physical file does not exist because it's looking for something that's actually called CSV file instead of this reference. So I can fix that, and again note this red cross which shows there's an error and it needs to be investigated. So I'm going to just create this reference for it, and then I'm going to run this PROC import statement again. And this is our data now in a very nice structured format: person, year, month, bonus. We can see that very clearly. We've no longer got that wavy data we need to deal with. And if we go to our work library, there's our bonuses data set in addition to the inventory data set. So we've got this data sorted. The one thing that I quickly want to just show you is, because a CSV file is a delimited file just like any other, we could have changed this CSV DBMS to DLM, which says it's a delimited file, and we could have simply specified to SAS that our delimiter is a comma in this case. And if I call this bonuses 2, it's going to give me the exact same result as previously. So it's as simple as that. I'm gonna take this one out because we don't need it. It's fine. I'll leave it in case you want to pause the video and just take a look and compare the differences here. But it's as simple as that. The last one that we've got to import is that dat file. I'm going to create a reference to it, and I'll run the reference as well, just so that we don't have another error. And this one is called vitals.dat. Now, we have no idea what's going on in this file, so we would need to go and do a bit of investigation, which we will as soon as I create this reference. Done. So let's view this .dat file as a plain text file, and let's see what's going on in here. Okay, we can look for words and things we recognize. So subject, day, SBP, DBP. We note that these values are all delimited by a certain character. In this case, it's an ampersand. So our DBMS is DLM for a delimited file, and in this case, our delimiter is going to be an ampersand. So it doesn't really matter what this extension here is, because this file is plain text. We can open it, we can investigate it, and we can import it into a much more structured data set. So let's go ahead and do that. And I mean, I haven't made these files available anywhere, but I've shown you the content. So this CSV file and this .dat file, pause the video, recreate it in any text editor, and you can then just upload it to SAS Studio, and you can work with it. If you're not familiar with how to upload something to SAS Studio, in episode 3, there are chapter markers. There is a short section that just explains how you can upload something to SAS Studio and work with it. So if you've got other data of your own that you would maybe like to analyze, again, if you're using SAS On Demand for academics, please keep in mind that it's for academic purposes. It's not for commercial work. But if you've got some data that you want to analyze academically, you can upload your own custom data set to the SAS On Demand for academics service. So let's link this dat file. We know our DBMS is a delimited file, and we're just gonna name it vitals. We could have named it anything we wanted. So the name here and the name there does not have to correspond. I'm just doing it because it makes the most sense. I'm going to leave out get names because it should default to yes, and that'll be a good demonstration as well. So we know it's a delimited file. We know our delimiter is an ampersand, and we have already mapped this reference. There we go. There's our names, even though we did not specify get names equals yes. There's our subject. So subject 1 has a measurement on day 1 and day 7. Subject 2, a measurement on day 1 and day 7. Subject 3, a measurement on day 1 and day 7. So each of these 3 subjects has 2 measurements, and they're measuring systolic blood pressure and diastolic blood pressure. And that about wraps it up for importing these raw data files. I'm going to jump back to the slides because I believe there was one more raw data item that we had to look at. So we've done all of this. We imported this twice, and we viewed it as a raw text file, and then we figured out what we had to do. Cool. So we are done with this exercise. Go and try this for yourself. If you've got a CSV file of your own or an Excel file of your own, by all means go and try your hand at it. Okay, so if you wanted to, you could limit PROC import to a subset of observations. The idea why the SAS prep guide goes through this is if you've got something with thousands and thousands of records. Excuse me. If you've got something with thousands and thousands of records, you don't want to, maybe it runs a couple of minutes. It probably won't because SAS is quite fast. The idea is that you save yourself some time, you limit it to 5 observations, and you just make sure that you've typed everything correctly and it doesn't error halfway through and waste your time. So you can limit that with an option statement. So you can say options obs equals 5, and if everything works as it should, you can just revert this with options obs equals max. Now, if I'm not mistaken, every time you submit a program, SAS will automatically revert to options obs equals max if a different one is not specified. But if not, if it keeps limiting your observations, you would just need to set it back to options obs equals max, and you would simply do it with something like let's just test it out. So if we options obs equals 5, recall that we had about 9 observations in here. So if we run this, why is it that things don't work when I want them to work? That should work, but I don't know why it doesn't work. Okay, you can review this in your SAS prep guide. It should be in there. I do not know. This happened yesterday as well with the XPT file. Appears your instructor is just incompetent, but please bear with me. I don't know. Let's try it with one of the CSV files and see if that works. It bugs me that it doesn't work. Okay. So for the Excel file it doesn't work, but for the CSV file it does work. So we know if these bonuses we had 5 people. We had Abe, Bob, Charlie, Dave, and Ed. So if we limit it to 3, we're going to get the row with the names. We're going to get the row with Abe, and we're going to get the row with Bob. So let's try that. Correct. Okay, so that works. So I'm not completely incompetent yet. And then, if I'm not mistaken, if we just take this out, SAS might just default back to obs equals max by itself, and it does. So if you wanted to just be completely sure, you could say options obs equals max, but you don't need to because SAS defaults to that anyway. Okay, cool. So we verified that works. For some reason it doesn't work for Excel files, but it works for the rest of the delimited files apparently. I don't use this in practice. That's just me. SAS is a fast system. I've never had the need to limit these things, even with a couple of thousand records. And I mean, everything that happened in the past 2 minutes, you can tell that I clearly don't use this very much and don't have a lot of experience with it. Okay, we've done this, so let's move on. The next thing that is in chapter 4 of the prep guide, again, these episodes kind of correspond more or less one-to-one to what's in the prep guide. Chapter 4 of the prep guide, again, go through some basics of the data step and the set statement. I'm not going to go over this again because in episode 1, episode 2, episode 3 so far, we have seen the data step and the set statement in action. I think it would be a waste of time if we had to do that again. The only thing that I would remind you is that the data and proc steps feed into one another. They're linked. One step's output is another step's input, and you can have a program with thousands of lines. I suppose ideally not. You would want it to be a bit more readable and maintainable than that, but you could have loads of data and proc statements, just changing things, putting it into a proc to be analyzed or something, taking the output from that proc, feeding it back into a data step, doing something with it again. You could keep doing that. You could daisy chain them forever and ever, practically. So that's important to keep in mind. So a data step and a proc is not meant to be one thing in isolation. You would, for example, proc import some data, feed that into a data step, derive a new column, maybe pop that then into a proc sort to be sorted, and then after it's been sorted, you can do something else with it again. So as long as you grasp that concept, then that's all good. If you do need to revise this, page 44 of the base prep guide, the 5th edition is the copy that I have. You can go and revise the information in there. Page 44. Okay, let's not waste any more time on the data step and set statements. The next one we're going to look at is a very useful one. It's the where statement. It is equivalent basically to, if you're coming from R, the dplyr filter function. So you would provide the where statement with a conditional statement, and then where that evaluates to true, it will keep that data. So if you say where, what's something simple that we can look at? Where sex equals male, it will keep all the males in the data set. If you say where age is less than 20, it will keep everything that's smaller than 20. Now, your where statement can have a number of conditional statements within it. So you can say where sex equals male and age is less than 20. You can combine it with and or and not. You can use the like operator. You can use the contains operator. So like, let's just take a step back. The like operator would be something similar to SQL, where you can have wildcards. You could have the contains operator, which basically asks, is one string contained within another string? You can use the in operator to check if a particular value, so you can have a list of values and then say, is this column I'm evaluating, is that value within this list of values? The important thing to keep in mind is that there can only be one where statement per data step. If you put, for example, 3 where statements in there, it's either going to keep the first one or the last one. I can't remember, but you can only have one. You can also just filter with an if statement, but there's something very important to keep in mind. So you could do, let's go back to my simple example, where sex equals male, semicolon. You can also do if sex equals male, semicolon. You can also do something like if sex not equals male, then delete, semicolon. But there are very important differences between where and if to keep in mind, and we're going to quickly look at the logic of the if statement today, not in detail. We're going to come back to it at some point. But even though on you know, at first glance, at a cursory glance, it will look like the where statement and the if statement are interchangeable and do more or less the same thing. However, the where statement is applied before data enters the PDV. If you don't know what the PDV is, go back and watch episode 1. You cannot learn SAS without properly understanding the PDV. The where statement applies before data even enters the PDV, and before by-group processing takes place, and before data sets are merged. The if statement applies after data has entered the PDV, after by-group processing has taken place, after a merge has completed. A merge, by the way, is similar to a join if you're used to R or SQL. But it's really important to know that these differences exist, because if you do not, and you're not aware of how data follows from input to PDV to output, and what happens within the PDV, then you're going to get results that really confuse you. This again, I told you in some of the previous episodes, you're going to get sick of me talking about the PDV. This is the reason why. The PDV, an understanding of the PDV forms a huge part of the SAS base exam. It's also a really big and important part of understanding how SAS works and ensuring that you are successful in your learning and understanding of the SAS system. For now, let's look at the where statement. We will, in future, we'll examine the if statement in depth, but we're going to focus on very simple where statements today. I think I set up some exercises we can do. I did. The first one, and we'll do them one by one because otherwise I'm going to forget what I'm busy doing. Use the like operator to find all brands in the shoes inventory dataset that start with A and have I as their third letter. Now, let's go and take a look at our shoes dataset. So we're looking for all brands that start with I and have, starts with A and has I as their third letter. If we, and now I'm going to go to our handy SAS datasets since we no longer have to work with the Excel sheets. Okay, so here's our brands. If we do a quick look, what starts with A? Asics and Adidas, and they both have an I as their third character. So we already have an idea what we want to filter on here. So let's do that. And let's say data shoes, close it with a run, and our input is the work.inventory dataset. So now we're going to add a where statement. The where statement follows the set statement, and we are going to say where brand like. We know it has to start with a capital A. The second character can be anything. The third character has to be an I, and it can be followed by any number of other characters. So this is a single wildcard. If we, for example, said, well, the fourth character has to be an I, we could have put 2 underscores in here, and that would have been the single character wildcard, and then this is the multiple character wildcard. So if we run this, we should get Adidas and Asics, which we do, and that's just important for you to be aware that that this is your single wildcard, this is your multiple character wildcard. The one thing I want to check is if you make this a small a, I believe it won't fail, it just won't return anything. Correct, because that, as we mentioned in, I think it was episode 1 or 2, SAS is not case sensitive for things like variable names and dataset names, but it is when you're comparing strings or characters with one another. So if we make sure to make that a capital A, we get the results we're looking for. Okay, let's look at our next one. Using the in operator, filter the shoes dataset on boots and sandals. So let's do that. I'm just going to call this one shoes 1. And I'm going to call this one shoes 2. And this won't actually execute until I run this again. And even if I run it again, there will be shoes 1 and shoes 2 in the work library. Ideally, you would go and remove the one that just says shoes to make sure that it's not overly confusing. But let's not worry about it too much at the moment. So we're saying we're looking for sandals and boots. We know that we've got sandals there, we've got boots there, and we have a type column. So we can then say we're type in sandals boots. You do not have to put a comma here. I put it in because it makes it more readable to me, but you do not need to. The only thing is when, for example, you do numerics. So let's say let's do something silly. Where quantity in 0, 1, 2, 3, 4. That is a lot harder to read than with commas, even though both of them are valid. Okay, so we've now got our in operator, and we've got this little, almost like an array of values. Arrays in SAS work a little bit differently, but we'll talk about that when we get to advanced topics. That's not for the base exam anyway. And there we filtered only on boots and sandals. So we know that code works. So we've learned about the like operator. We've learned about the in operator. So let's move on to our third exercise. Assume a normal blood pressure range of 120/80. I think we're all familiar with that. Find all records in the vital signs dataset where either SBP or DBP is lower than the normal range. So if SBP is less than 120 or DBP is less than 80, I'm going to close this inventory dataset, and I'm going to go look at our vitals dataset. Notice there's shoes and shoes 2. I've not rerun the bit that I've renamed to shoes 1, so that's still not in there. Here's our vitals dataset. Let's just remind ourselves, subject, day, SBP, and DBP. So we're looking for SBP less than 120, there's an instance, and we're looking for DBP less than 80, there's an instance. So if we start with that, let's call it, I don't know, vitals low. And then we can simply say set vitals where SBP is less than 120 or DBP is less than 80. The one thing that I just want to mention here, and we can look at that as well, is you don't have to use these. There's certain things to look out for when you're using these operators of less than or greater than. So let's quickly run this and see if it works. It does. We've got one record where either this or that is lower. In our case, we were just lucky that both of them were lower. So if you wanted to, for example, say where it's less than or equal to 120, you would do it like this, or less than or equal to 80, like that. Greater than or equal is as follows. Something to keep in mind is that you cannot do equals greater or equals less. It will work in normal data step code It will not work in a where statement. It will not work in PROC SQL. You shouldn't be using these. They still work in data step code. So if you were just doing an if statement here or something, they will work. That's to preserve compatibility with older versions of SAS. You shouldn't be using them anymore. The other thing to keep in mind is that you don't have to use these operators. I would hope that if you're a programmer or a statistician or whatever the case may be, you're familiar with them. You could also use different statements. So less than or equal, you could use the LE. Greater than or equal is GE. Come on. Still getting used to my Mac key bindings. We have less than is LT. We have greater than is... Why does it not want to play along with me today? Greater than is that. Your equal sign. And testing for equality and assigning both use an equal sign, so there's no double equals for equality or anything like that. It's EQ. Not equal can be, I normally use the caret, so that could be NE. Let me just think what else I might be missing. I think that's about it. Yeah, but you more or less get the idea. So instead of me saying, you know, initially our instruction was less than, instead of saying that, I could have said LT or DBP less than 80, and that will still work. So you can use those shorthands that I wrote out just now: less than, greater than, less or equal LE, greater or equal GE. You can say, for example, where it's equal and equal, or equal and not equal. I honestly prefer just using the mathematical operators. In the same way, instead of using the OR keyword, I believe you could use a single pipe. And the AND keyword is either you can type AND or you can use an ampersand, a single ampersand. I prefer using the mathematical operators for dealing with less than, equal to, greater than, all of that. I like personally using the AND and OR keywords because they read easier. And just one thing to watch out for: if you're coming from a language that maybe uses double ampersands for the AND, I think C# and Java use double ampersands for AND, so that won't work. And the pipe one, if you have double pipe, that's actually not an OR, that's SAS's concatenation operator for putting strings together. But a single pipe is valid for an OR keyword. Okay, we've done this one. And then the very last one, and this is a bit of a silly one. I don't know anyone who actually uses this operator, but SAS has an operator that's called the sounds like operator. And so if you have one word that sounds like another word, SAS will return all of those. So if you, for example, have say something that sounds like Smith, and you have both Smith and Smiths and Smith in a column, then SAS will say, okay, well, all of these sound like Smith, and will return all those to you. So in this case, it's saying, let's look at the bonuses data set and let's find something that sounds similar to Charlie, and we'll also try it out with Ave. So let's look at our bonuses data set. And we've got Abe, Bob, Charlie, Dave, and Ed. So we're going to be using that sounds like operator on the person column. Apologies, my throat is not in good condition today. I think it might be the cold. So let's do data, bonuses, sounds, and that's coming from our bonuses data set. If we run this, we're just going to get our data set back. So we've got Abe, Bob, Charlie, Dave, and Ed. And now we were asked to say where person sounds like Charlie. Now, as I've said, this is a bit of a silly operator to me, and also not very reliable. But Charlie sounds a lot like Charlie, and so SAS returns Charlie to us. If we try Ave, and this is where it gets a little finicky for me, is it says Ave sounds like Abe, but apparently Ave does not sound like Dave, even though it's pretty similar. So this is not a very reliable operator. I included it here as a bit of fun, but you needn't worry too much about this one. I don't think I have ever actually used this operator in my professional career. That about wraps it up for exercise 4.2. I'll just add a comment here at the top to be neat. Exercise 4.1. That's neat and consistent. That's 4.2. Let's move on back to the slides and see if we can start wrapping up. We're at 9 out of 13, so we're almost there. One other thing that's in the base prep guide for this section is the drop and keep statements. We can look at it very briefly. The main thing is that similar to, and I'm again going back to R, if you're coming from R, you have the dplyr select function, and if you wanted to keep something, you would just put the name, and if you wanted to drop something, you would put a minus in front. This does the same thing, so you've got drop statements and keep statements, and you've got drop options and keep options. And so we can look at the difference between the drop and keep options and statements. Let's take this vitals data set. So I'm just going to say drop keep options versus statements, because that's what we're looking at now. So if we say data my vitals run set vitals, and let's copy this option here. We've got it's going to do exactly the same thing as this vitals low, so I might even just overwrite that data set. So if we've got an option, then that means that either goes to the data or the set statement, for example. So there's a difference between when we call something a data set option and when we call something a statement. So let's use the keep option for now. So we know that in this vitals data set, we've got subject, we've got day, we've got SBP, and we've got DBP. So we know that with the where statement, we're going to return this one record. There's only one record where it is true, and that's for subject 2 on day 1. So let's say that we're not interested in knowing the exact SBP or DBP. We're just interested in whether it's lower or not. What we can do is we can simply say drop SBP and DBP, and I believe here you do not put commas because it will give you an error. So here it's just spaces to separate the names. If we do this, we should see subject to day 1, because this where statement executes and then it drops SBP and DBP. And that's exactly what we have here. So we have subject to and we have day 1. And I need to move my camera because my camera is in the way. Give me 1 second. Let's do that. Now I'll move there. Cool. Subject to day 1. So we've got we've got that. We know that works. We could also do. So that was a statement. So if you've got it in line like that, that's a statement. If you do something like this, drop SBP DBP, that is called a data step option. So this will do the same thing. We've got subject, we've got day, and it's dropped SBP and DBP, but it's still the correct result. However, something to keep in mind is that this drop executes at the end of the data step. If I move this drop statement in here, that's going to drop SBP and DBP as it's reading in the values, I think. The question is whether it does that before it does the where. So if you tried that with an if statement, it would definitely fail because this would not be in there. With a where, I'm not sure whether it will fail or not. And it does, thank goodness. So this dataset option to drop it executes even before it does the where, and the where executes pretty early because that's before it even goes into the PDV. So you can see because we've dropped SBP here, SAS runs into an error and says, sorry, but this variable does not exist. And it doesn't exist because we've dropped it. However, if we don't do it here, if we do it either as a dataset option here, or we do it as a statement, then this where statement executes successfully. Now, why would you want to drop something in here? Well, it's very useful, for example, if you want to merge two different data sets, but you want to drop something from the one data set before you join the two together, either to avoid data being overwritten, or maybe there's two columns that have the same name, but the one is very different from the other and is no longer needed. So you will have your reason sometimes for dropping something, dropping some columns before you do something else. The keep statement works in pretty much the same way. So if we only wanted subject and day again, instead of saying drop SBP and DBP, we can simply say keep subject and day. Again, this is a statement. We'll look at the option just now. There's subject and day. And if we wanted the option, it would look like this. Keep subject and day. And again, this is after everything is done. If we put this keep option next to the set, next to vitals, then it would only keep those two and drop everything else before it even got to this where statement, and you would see an error. There we go. So that's the basics of the drop and keep statements, and also them as data options. Very useful for sort of tidying up your data set and not keeping unnecessary columns around. Now the last topic for today is the output statement. This is very important to understand. This is something that will go hand in hand with the PDV, and I'll show you something that is that's a bit above and beyond when we get to the actual PDV chapter, which I think in the prep guide is either chapter 6 or chapter 7. As I've said in my course, the PDV is chapter 1 because that is the most important thing you need to know. But we'll figure out how to combine the output and the PDV statement to do some pretty cool stuff. The one thing to keep in mind for now is that every time you run a data step, the very last thing that SAS executes is an output statement. So what I mean by that is, if we let's start a new section for this. And so what I mean by that is, if we do something like let's just call it choose. If we run something like this, we get our shoes data set, but what is really happening is this. So if you don't specify one, SAS will put one here, even though you never see it. And the very last thing that it does before the run is the output statement. So we can see if we manually put an output statement in there, we still get the same 9 rows in the same order, and all of our columns stay the same. But we've just taken control of the output. And so here we have an implicit output, and if we put it in, that's called an explicit output. Now, your explicit output statements will override the implicit output statements. So something to keep in mind is, let's do something similar to what we did yesterday, which was value is price times quantity. So in episode 3, if you've not seen, we simply took quantity times price and then said, well, what's the value of the Nike sneakers stock? What's the value of the Adidas sneakers stock? And so if we run this, we'll get that value column in there. And that would be the default as well if we left that output statement out. If we move this output statement one up, we are overriding the implicit one that would have appeared here at the end. And this is now what our data set looks like. Why is that the case? Because we have to remember again how the PDV works. So what is happening is that SAS loads these 4 columns into the PDV. Before you calculate the column that says value, you tell SAS to output what you've got in the PDV into the output data set. So in our case, that's work.choose. So it's got these 4 columns in there, and then you tell SAS to output that. Then SAS calculates the value, but because there's no output statement after that value calculation, because we've overridden the one that would normally be here, that means that within your PDV, that value column is added, but it is not output. It's not written out. So then SAS will initialize the next record, because it passed the bit where you've calculated the value. It initializes the PDV with blanks. It loads in the next record, which is sneakers, Adidas, 50 and 100. And then it outputs that. Then it calculates what is 50 times 100. But there's nothing to... that is never written out, because there's no output that follows it. Because our explicit output statement has overridden the implicit output one. And again, if that does not make sense, go and watch episode 1 with the PDV again. you can have multiple output statements. So let's run this and see what happens. Again, as you're looking at this, maybe take a moment, pause the video here, and ask yourself, what is the PDV doing in this scenario? Take a minute and think about it. We're reading in the record as it stands. That goes into the PDV. We output what is in the PDV. We add a column called value into the PDV, and we output what is in the PDV. Let's run that and see what happens. Now, notice that before we had 9 records. Now we have 18 records. Each one of these records now appears twice. The first instance of the record has a blank value column. The second instance has the value calculated. I hope this makes sense. I hope that you understand that from the input, when data goes into the PDV, and while it remains within the PDV, we can output it multiple times, because when we write code in the data step, and when SAS is busy with a particular record, that code that we have in there can be applied multiple, all of that code is applied to the record that's in the PDV. So if we issue multiple output statements to SAS, it'll just take what's in the PDV and write that out several times. And that's why that golden thread of input, PDV, output is so important to understand. And we'll see how we can, for example, manipulate the PDV to I'll show some examples. We'll look at something that we use, for example, when we do programming in the pharmaceutical industry for conmeds, how we sort of expand the dates across which conmeds happen, and we'll figure out why and how we can manipulate the program data vector. So that's a very, very useful thing to know. It's very, very important that you understand this as well, because it again, output and PDV go hand in hand with one another. The other thing you can do is that you can direct output to multiple data sets, which is very useful. And I've already hammered the point home, this last one that says it can be a very, very powerful tool. So the last exercise we're going to look at today is about directing output to multiple data sets. Let's do that. Exercise 4.3 is about using the vital signs data set, and we're going to divide the records into 3 data sets. We're going to have a data set called low, where the records for SBP is less than 120. We're going to have one for normal, where the records for the systolic blood pressure is equal to 120. And we're going to have a data set called high, where the systolic blood pressure is greater than 120. We're going to learn more about the if statement in this exercise. That's something we've not looked at. But we will look at it now, at least the very basics of it. And then I've already mentioned that you can decide whether you want to use the mathematical operators or you want to use the keyword operators. I've already said don't use these versions where the equal sign comes before the smaller or larger than operator. They will not work in where statements, and they won't work in PROC SQL. Use less than or equal, greater than or equal in that order. So this is a pretty simple instruction. Let's find low, normal, and high SBP. And we could even expand on this exercise, and we can say, well, since we're not looking at the diastolic blood pressure, let's just drop that column as well while we're at it. So let's do that. And then we are done for the day. Okay, exercise 4.3. I'm going to leave this blank for now. And you'll see why soon, because I want to just impress something on you. So let's build this block by block. We know we're supposed to have a data set that says low, one that says normal, one that says high. We know that what goes next to the data step statement is the names of the output. And notice that this time I said names plural and not names singular. So here we are telling SAS that we have 3 data sets that we want to output to. And if we run this, our low, our normal, and our high data sets, sometimes the columns don't render the same. In this case it's a bit longer than the others, but who knows why that happens. So subject, day, SBP, DBP, they're all exactly the same. We know for a fact we will not be using DBP, so we can just drop it. If we do that now, we have subject, we have day, and we have SBP, subject, day, and SBP. And we are outputting the exact same data set to all 3 of these data sets. Now, if SBP less than 120, then output to low. Notice what's happening here. If the systolic blood pressure is strictly less than 120, then output to low. That's this one here. That's the name of a data set. So we are controlling the output from the program data vector and saying, if this condition holds true, the output goes to this data set. But likewise, we can say if SBP is 120, then output normal. If SBP greater than 120, then output high. And these are all names of the data sets that we defined in here. So these are 3 different output data sets separated by space. They all get their input from this vitals data set, as we saw, if we don't take control of the output statement. If we leave it with an implicit output, they are all the same. Once we take control of explicit output statements, we will see a difference. So let's run this. Let's go look at our log. And you will notice now the log talks about 4 different actions. So the log states that we had 6 observations from the original vitals data set, that the low data set has 1 observation, the normal data set has 1 observation, and the high data set has 4 observations. And if we go and actually look at our data sets, subject 2 day 1 has systolic blood pressure of 110, that is lower than 120. Subject 1 day 1 had a systolic blood pressure of 120, that is equal to the normal. And then these guys, 123, 125, 130, 135, these 4 of the 6 had a systolic blood pressure higher than the normal. And so that is the difference between implicit and explicit output statements and how we can take control of it. Try it again, try this in your own time, redo this exercise until it starts making sense. Understand that DBP was dropped before before SAS even looked at these if statements. You could have also done something like this. But then you would have to specify it for each of these data sets instead of just once as you're reading it in. I'm going to take those out because they're just wasting space and being confusing, but as long as you're aware of it, then that's fine. Okay, this was a nice quick exercise. We will look at the output statement again when we revisit the PDV and we try and do more complex things with it. But that wraps us up for today. Next week we will be looking at how we can identify and correct errors. So there's different types of errors that you can come across. Sometimes you have mistyped something. Maybe there's something unexpected in the data. So we've got different errors we need to look at. Syntax and semantic errors. It's in the second bullet point. We're going to look at the underscore n underscore and underscore error underscore variables that are within the PDV. So as the PDV is stepping through your data, the n variable increments by 1 every time it steps through another record. The error variable is flagged if an error occurs while it's processing a particular row. And while those exist within the PDV, they are not output by default to your output. But you can reference them in the PDV. So if you, for example, have 10 records in your data set, you can say something like if underscore n underscore equals 5, then output, and that'll output only the 5th record, for example. And you'll never see n in your output, and you won't see it in your input. It only exists in that middle part for the golden thread. It only exists in that part where the PDV is. And then the last thing we'll look at are put log and put statements. That's just a way that we can write some output to the log, or we can write some output to the results tab, maybe to help us debug something. What's often very useful is if you've got a bunch of records, say you're looking at demographics of patients, and you've got 10,000 records. It might be very useful to have something in your output, in your results or in your log that just says, by the way, within these 10,000 patients that you're looking at, 5 of them have a weight less than 10 kilograms. Maybe that should have been, maybe it was recorded in a different unit. Maybe that should have been 10 stone or something instead. Who knows? But it's very useful to have these little helper statements that you can program to output little warnings or messages or something for you to look at. But that'll be for next week. That's not for today, and it'll probably only be next weekend as well. I normally do these episodes on weekend. I do have a real job that does not allow me enough spare time to do these during the week, so I do them on weekends. As always, thank you very much for watching. If you've put up with my rambling and my waffling, it is appreciated. Please, you can leave a comment, you can like, you can subscribe to make sure you get the latest videos in your subscription feed. And feel free to let me know if there's areas where I can improve on, or if there's something extra that you would like to see me cover. Alright, until next time, thank you and cheers. Bye bye.